Algebra 1 Common Core, Unit 4, Section 5, Consecutive Integers. Well, if this isn't your first video from me, you could obviously tell my voice is very different. I've been losing my voice for the past couple of days and still need to get this video done today, so maybe I'll re-record it someday if my voice ever gets better. But for now, it is what I got, so hopefully you could understand what I am saying. But consecutive integers, the notes up here are very valuable and do a good job of explaining what consecutive integers are. Let me go to a thicker highlighter there. Consecutive integers are integers that follow each other in order, such as 8, 9, 10, 11. Consecutive means, next one up. When solving consecutive integer problems, we assign the first integer the value of x. So like you see here for these examples, find 2 consecutive integers or find 3 consecutive integers. The first thing is we have to let our first integer be x. And then our second integer is x plus 1. The reason why we let our second integer be x plus 1 is because, let's say our first integer is 8, and then it goes 9, 10. Well, if this is x, the relationship between 8 and 9 is 1 more than x. So 8 plus 1 is 9. And our second integer would be x plus 2. So 8 plus 2 is 10. So whatever your first integer is, if you let that be x, x plus 1 is 1 more than that. X plus 2 is 2 more than the original, which is 1 more than the second, so on. And if we had a fourth integer of 11, we would call that x plus 3. And so this is what you're going to use when you are, setting up your consecutive integer problems. You're always going to let the first one be x, your second one x plus 1, your third one x plus 2, and then you translate what they need you to do here. This example for this particular problem, so since the next consecutive integer is 1 more than the previous, we let it be x plus 1 and so on. So this example in here says find 3 consecutive integers such that their sum is 24. So that means that the first integer plus the second integer plus the third integer equals 24. And since we're letting that be x, x plus 1, and x plus 2, that's those expressions added together. And you literally add these expressions together. X plus 1 plus x plus 2 comes out to be 3x plus 3 equals 24, and then just subtract 3 to, solve. So let me do an example for you. Find 2 consecutive integers. So since I'm finding 2, I'm going to let the first one equal x, and the second one is going to equal x plus 1 because it's 1 more than the first, such that their sum is 21. So that means that it's the first one plus the second one. Their sum is 21. And I like to write it like this first before I put in any x's, like first plus second and stuff like that. So you'll always see me do that. I think it really helps when you're setting it up. So the first is x, your second is x plus 1, and the sum is 21. And once you get down to this phase, now it's just solve the equation like we've been doing. Combine your like terms, if you have any parentheses, distribute, etc. X plus x are like terms. You could combine that to be 2x plus 1 equals 21. I can subtract 1 on both sides to get 2x equals 20 and divide 2. So x equals 10, which means the first integer is 10, and x plus 1 would be 11. And those are your 2 integers. Sorry, that 10 kind of looks like a 6. It's a 0. Let's try another one. This time it's 3 consecutive integers, so that means I'm going to have x, x plus 1, x plus 2. And x plus 2 is really x plus 1 plus 1, right? Plus another 1 further away. Such that the sum of the sum addition of the first 2, so the sum of the first 2, so that's the first plus the second, is always means equals 4 more than the third. So that's your third plus 4. And then you should kind of read this again, but look at this. Such that the sum of the first 2, first and the second added together, is 4 more than the third. Okay, so that looks right. And now I can replace first, second, and third with these values. First is x, second is x plus 1, third is x plus 2, and plus 4. Simplify the left, we get 2x plus 1. Simplify the right, we have x plus 6. I got x on both sides, so I can move one to the other. Maybe minus x here, minus x. 2x minus x is x. Plus 1 equals 6. Minus 1, x equals 5. And then I always tend to put this on the left, and then I put the answers over here. Because remember, x isn't, it's not find one integer, it's find 3. Find 3. So 5, and then 5 plus 1 is 6. Plus another 1 is 7. So 5, 6, and 7. So that's when the problem just talks about consecutive integers. But sometimes it gets a little bit more complicated by changing it to consecutive even or odd integers. So like consecutive even would be like 6, 8, 10. Consecutive odd, 5, 7, 9, like the next even integer. Now we still assign the first integer the value of x, no matter what. Whether we're talking about even or odd, this doesn't change. But, if we go on the basis of, again, let me write this down, like 6, 8, and 10 for even, or 5, 7, and 9 for its odd. If I make the first integer x, it can't be, the next one isn't 1 away. Since the second is 2 more than the first, x plus 2 is the second. So, here we were doing x and then x plus 1, x plus 2, x plus 3, x plus 4, because the integers are 1 apart. But even and odd integers are 2 apart, right? Regardless of what the even integer, the next even integer is 2 apart. And then the next one is another 2 apart, so that would be x plus 4. Now, people tend to make sense out of that for even, but it's actually the same thing for odd. Sometimes people want to say plus 1, plus 3 and stuff for odd, but no, it's still this. It's still x, x plus 2, x plus 4. Because if I make the first integer x for an odd number, the next odd number is still 2 away, because numbers go odd, even, odd, even, odd, even. So to get to the next odd number, it's still plus 2, and then another plus 2. So you're going to use the x, x plus 1, x plus, just going up by ones for regular consecutive integers. But if it's consecutive, even, or odd, we go x, then x plus 2, then x plus 4, and if we had a fourth, it'd be x plus 6. Again, even or odd, that doesn't matter. That's important. Because a lot of people are fine with even, but when it's odd, it confuses them. This demo right here, it's find 3 consecutive odd integers. And even though we're finding odd integers, we still use x, x plus 2, and x plus 4, even though they're odd, because they're still 2 away from each other. That's the key. And then it works out to 9, 11, and 13. So there's one more example I want to do for you. It says find 3 consecutive odd integers. This is actually supposed to say even. So you could change that on your paper if you printed this out. Find 3 consecutive even integers such that so first of all, 3 consecutive even integers. So that's going to be x is the first, x plus 2 is the next even integer, and x plus 4 is the next even integer. All right, so then what does this translate to? Double the third, so that's 2 times the third, increased by the first, so plus the first, is, so double the third increased by the first is 6 less than, remember 6 less than means minus 6, not 6 minus, 4 times the second, so 4 times the second. Again, after you do that, you should reread it. So double the third increased by the first, so that looks right, is equals 6 less than 4 times the second. Okay, so now I can replace third and first and second with these values here. And so the third is x plus 4. The first is x, and the second is x plus 2. Right? Some people like to write first, second, third. We always want to get rid of parentheses first, so we'll distribute first. We distribute this in. Let's go back to green. 2 times x plus 4 is 2x plus 8 plus x with nothing in front of the parentheses, just x equals 4 times x plus 2 is 4x plus 8 minus 6. Clean up the left like terms is 3x plus 8 equals, clean up the right, 4x plus 2 from the 8 minus 6. You can subtract 3x over here to get the x terms together. That's going to give us 8 equals 1x. Oh, sorry. 8 equals 1x plus 2. You can write the 1 if you want. Subtract 2. Subtract 2. 6 equals 1x, which means 6 equals x. So that means our first is 6, our second is 2 more than that, is 8, and our third, 2 more than that, is 10. So 6, 8, 10. All right, so that's consecutive, even, odd, and regular consecutive integers. So remember, if it doesn't say even or odd, it just goes x, x plus 1, x plus 2, x plus 3, so on. But if it's even or odd, it's the same procedure. It goes x, x plus 2, x plus 4, x plus 6, and so on. All right, that's consecutive, even, and odd integers and consecutive integers in general. Unit 4, Section 5. See ya.